Okay, section 7.3 is kind of a step back from what we got started with in 7.1 and 7.2. We talked about how if you're going to graph a rational function, you need to be able to factor the denominator to see where those discontinuities happen. And so in 7.3, we just kind of stopped that progress and just focus on factoring and multiplying polynomials. Probably, maybe nothing that you've never seen before in this section. So I'll try to make it a quick video. So number one, let's talk about multiplying polynomials. And usually when you multiply a binomial times a binomial, you call it foiling. The same principle happens if you are multiplying more than two terms by two terms. So I'm just going to do one example where I have more than that. X squared minus 4x minus 7. And x squared minus 2x plus 5. And the FOIL is just a memory trick to help you remember that you multiply every term in the first one by every term in the second one. So I'm going to multiply, if I have more than this, multiply the x squared by all three terms, and I'm going to multiply the negative 4x by all three terms, and then I'm going to multiply the negative 7 by all three terms. So if I have a 3 by 3, I should expect 9 terms before I combine like terms. And really this just becomes a bunch of separate little calculations all together to give you one answer. So mistakes that happen here usually are just missing a sign or a small mistake that you know better on. So when I distribute my x squared through all three terms in the second polynomial, I get x to the fourth minus 2x cubed plus 5x squared my first time through. Now I'm going to group these terms vertically. You don't have to do this, but I would suggest it. When you start to distribute the negative 4x, you get negative 4x to the third and plus 8x squared and negative 20x. If I just keep all my x cubes lined up and all my x squareds lined up and all my x's lined up, it's just going to make it easier to combine like terms in a few minutes. Now I distribute my negative 7, I get negative 7x squared plus 14x minus 35. And then, like I said, just add vertically. You don't have to do that. You could just write a big long list of 9 and then combine the like terms. But this just is an organization thing. Minus 6x cubed. Let's see, that would be plus 6x squared. And minus 6x minus 35. And like I said, I don't think you've never done this before, so we'll move on quickly. But that's how you would multiply two polynomials together. Okay, next is going to be factoring quadratics. And this is one you'll use a lot in this chapter because when you work with a rational function, several occasions require you to factor the top of it or the bottom of it. And so you have a lot of times where you factor quadratics for that reason. So let's start with one like 6x squared plus 19x minus 20. And there's a couple approaches to this question. I was always a fan of just guess and check and finding it and making it work. There are different methods. There's a box method. There's an AC method. I'm going to show you just guess and check because that's what I would do. And then I'm going to show you the AC method. Really, all those methods, if you've learned one from a previous teacher, they're all doing the exact same thing, just in kind of different orders and different arrangements. So if you have a way to factor this, by all means use the one that you're comfortable with. If you're going to guess and check, this one, because 6 has a couple different factors and because 20 has a few different factors, there's a lot of different options to guess and check. I could go here 3x and 2x, or I could go 6x and 1x. And then the negative 20, all the different possibilities of negative 20 are 20 and 1, and one of those being positive and one of those being negative. So that's negative 20, positive 1, or positive 20, negative 1. You go 10 and 2, you could go 5 and 4. So some combination of those numbers, those factors of 20, one being positive and one being negative, needs to go in these second spots. So it actually, in this case, guess and check might take me a little bit to pick the right one. So let me just try something like minus 5 plus 4. And what you're doing is you're checking to see if you were to FOIL this backwards, would you end up with plus 19x in the middle. So in this case, I have 12x from my outers, and I have negative 10x from my inners. So that's a total of 2x, which is not 19x. So that means something's wrong with this arrangement. The frustrating part is I don't know if it's the 5 and the 4. I don't know if it's the 3 and the 2. It's just a lot of different combinations of checking. So I'm just going to kind of cut to the chase. Imagine that I guessed and checked all the different ways that I could. And I'm going to get to x plus 4 and 6x minus 5. And that one actually might have taken several minutes to guess and check the right combination. But once you factor it, every time, I mean, you don't have to write down this checking process every time, but just give it a quick FOIL in your head. I've got 6x squared, which is what I want. I've got negative 20 from the L's, the lasts in FOIL. And then on the inside, or the O and the I for FOIL, I've got negative 5x plus 24x, and negative 5 plus 24 is plus 19. So that tells me that it works. So just like when you solve an equation, you should always plug x back in and check to see that you got the right answer. When you factor something, multiply it back together to make sure you got the right answer. So I'm going to rework this same problem with what I call the AC method. And like I said, it might look similar to one you've done. I haven't found one that's any different. It's just, it might look slightly different, but in reality, it's all doing the same thing. So what you do first in this method is do A times C. And that's A and C, as in ax squared plus bx plus c. So my A times C is negative 120, because 6 times negative 20 is negative 120. Step 2 is to break down the 19x, or break down the 19 into two factors of negative 120. So to get negative 120, I could do negative 60 times 2, or 60 times negative 2. I could do 3 and 40. I could do, let's see, I could do 4 and 30. I could do 6 and 20. I could do, what else goes into 120? And I could do 5 times 24. So that's the one that ends up having a difference of 19. So basically what I'm going to do now is take plus 19 and write it like this. Plus 24x minus 5x. And then just add the minus 20 onto the end. So step 1, multiply A times C. Step 2, find two factors of AC that add up to B, basically. And all I've done is I've worked backwards and separated this out. Okay, step 3, group the first two terms together. Looking just at these two terms, and then looking at these two terms, what do they have in common? Well, my first two terms have a 6 in common, and they have an x in common. So I'm going to factor a 6 out of just those two terms. And I'm going to be left with an x plus 4. My next two terms have if there's a negative in the middle, include that with it. They have a negative 5 in common. So I'm going to factor out negative 5 and be left with x plus 4. In the AC method, if these two things do not match up, then there's a problem. So you should have two of the exact same binomial after you factored the first two terms and factored the second two terms. At this point, I'm going to factor that binomial out of this term, this is one big term, and this is one big term. They both have an x plus 4 in common. So if I bring that x plus 4 out to the front, my first term leaves me with a 6x, and my second term leaves me with a 5. And you'll notice that's what we got the long way above, the guess and check way. So, like I said, you might have drawn a box or done something slightly different than this, but they're all going to lead you to the same result. And by the way, if you had broken down 19 into negative 5 plus 24, you're going to get the same result. Once you try that one on your own, what if you had done 6x squared minus 5x plus 24x minus 20, and you had flip-flopped those from the way I did it? Try that to convince yourself that it would be the same either way. And again, I would just FOIL this out real quick to double check and see that I got what I was looking for. So that's AC method. One more thing for this section is difference of squares. And this rule is based on what do you get if you FOIL two conjugates. All right, two conjugates are a plus b and a minus b. If I FOIL these, I get a squared plus ab minus b squared, which is a squared minus b squared. And factoring a difference of squares is doing this backwards. So if you see two perfect squares with a negative in between, you're going to factor it this way. And if you ever see two terms, most likely it's going to be this, because there's not a whole lot of other ways to factor just two terms. So here's a quick example. Start with 49 minus 9x squared. Okay, so 49 is a perfect square. You don't have to write this every time, but just the first time through I'm going to be thorough. 9x squared is a perfect square, and it's quantity 3x squared. So to factor this, all you have to do is do 7 in the front spots, do 3x in the other spot, make one of them plus, and make one of them minus. If you were to FOIL this back out, you'd get your 49, then your O and your I terms would both cancel, and then you'd multiply 3x times negative 3x and get negative 9x squared. Last thing, you might get an example that looks like 27 minus 3h squared. Now, those numbers are not perfect squares. 27 isn't a perfect square, and neither is 3h squared. But I see only two terms, and they have a minus in between. And really, all I know right now with two terms is to do a difference of squares. So something else needs to happen. Anytime you factor, this is just a general statement for any factoring of any style in any level of a class. If there are two terms or more that have something in common, you need to get that common stuff out. These are not perfect squares, but they both have a 3 in common. So factor your 3 out, and you get 9 minus h squared. And now you can see that I'm left with a difference of 2 squares. So the 3 stays out front, and then the 9 minus h squared becomes 3 plus h, 3 minus h. And that's now completely factored. Factoring completely means keep factoring until everything left is prime. Okay? So that's our 3 topics in 7.3. We have multiplying, where it's more than just FOIL. It might be 2 terms or 3 terms or 2 times 4 or 3 times 4, lots of terms. And this is just a matter of being organized and careful and not missing a negative sign. Then we have factoring quadratics. You can do guess and check. You can do a method. My method's the AC if I'm going to use one. And then we have factoring a difference of 2 squares. So look for 2 terms with a negative in between them, and if they're both perfect squares, factor them with this method. Okay, so that's 7.3. I hope you enjoyed listening to it as much as I enjoyed saying it, and I will see you in class. Young out.